Welcome, everyone. Tonight, we welcome to the GSD Sarah Oppenheimer, a really remarkable artist whose projects engage architecture and space. Well, space, you could use this word more abstractly, more broadly. Her work actually eludes categories, so when we use these words, they mean many things in different ways in her work. Anyway, she is really someone who has done so many projects and has so many achievements and awards. I don't want to tell you the whole list because it will take too long, but I'm sure many of you know, and I will just give you a few highlights. Her work has been practically in all of the important museums. You know, the Andy Warhol. She's been in Art Basel, of course, and St. Louis, and this remarkable piece, the Mattress Factory. Many of you, of course, know. Projects more recent, really a great piece at the Wexner Center, Pérez Art Museum in Miami, Luxembourg. You'll hear about them, I believe, I hope. A very important embedded permanent exhibition at the Baltimore Museum of Art. These, among others, and many important awards, among them the John Simon Guggenheim Memorial Foundation, the Rome Prize, the Joan Mitchell Foundation Painters and Sculptors Grant. I can't do all of them, but she's someone so deserving of this, I think because of what I mentioned already, the particular way that her work intersects different domains. It's somehow, as I said, operating within architecture in a highly unusual way. She uses, if I may say, certain kinds of forms to operate on buildings, to produce, in particular in that project that I mentioned at the factory, at the Mattress Factory, to produce remarkable voids and introduces also large-scale fragments, I would say, of buildings. This is how I see those things. And working with materials in a very unusual way against the opticality, in a way, of the materials, the way they produce effects. And in doing that, along with the voiding and introduction of these giant scale interventions, really changes the space of galleries and museums. She is sometimes called someone that makes installations, but I don't think these are installations per se, if I may say so. They're something like instruments with which to revise buildings, to reconfigure architectural conventions, particularly those conventions that involve temporality and spatiality as we understand it. She, in a way, is like making interpretive acts. She's performing interpretive acts on buildings that physically and cognitively alter them. I don't want to say too much more about what she does because another part of this, which is so exciting for me, is that her work involves an exceptional kind of way of working on problems discursively. I have not had so many occasions to introduce someone who articulates in the way she does a mode of thought that's so directly connected to what she is doing. And so this is something so special, you know, to have someone sometimes called a sculptor. She doesn't think she's one. She doesn't like to call herself that. Sometimes called an installation artist, but if I were to call her something, I would have to say, and I hope she won't mind, that she's one of the most interesting architects that I know working today, oddly enough, even though, in talking to her, she really has not been teaching or studying in schools of architecture. So anyway, with all of that, we welcome into our world this very unique figure. I'm so delighted to have her tonight to extend the discussion of her work further. Welcome, Sarah.
Hello. This is an interesting contraption, so I will do my best to adapt to it. I want to say, first of all, thank you very, very much for having me here tonight. I have looked at this institution for many years at a remove, and it's really exciting to join you this evening and talk a bit about what I do. And I also want to say it's very nice, Scott, to receive an introduction from you, because your text on one piece in particular about a hole in Rome really changed my reading of that entire city. And I spent quite a bit of time following your strands of thought. And it was a really extraordinary investigation that you prompted and shaped in my mind from afar. So I am very, very grateful for that. Thank you. So without further ado, I am going to dive in. A building's material boundaries create an ever-changing relay of immaterial trajectories. Windows reflect daylight, doorways mediate procession, vents direct airflow. These forces modify the built environment in turn. Daylight penetrates material surfaces, expanding and contracting construction joinery. Living bodies generate live loads, shifting structural slab and non-structural partition walls. Buildings are time-based. The temporal cycles of each building vary in duration. The sun moves across the sky. People walk through a room. A door swings open and closed. These temporal cycles intersect and overlap, oscillating between phase offset and coordinated synchrony. The pieces I will be discussing today, entitled D33, 33D, S281913, S337473, and S011110, change over time. Each injects their specific durational periodicity into the cyclical life of an inhabited building. Boundaries create the illusion of stasis. Walls, floors, ceilings appear fixed and unchanging. Alterations to the boundary's thickness, materiality, and infrastructure shift spatial relationships between inhabitants, often imperceptibly altering a space's contours. D33, created in 2012, modified the relationship of the boundary plane to this material infrastructure. The exhibition space was divided into 6 discrete rooms. Structural columns, here indicated by hatched white lines, were located at the intersection of existing boundaries. By shifting the spatial relationship between boundary plane and structural grid, intersections between the 6 adjacent spaces could be removed. Sightlines and passage between the 6 rooms was rerouted through these voids. Visitors entered the space from a central quadrant and could travel through the corners of the 6 zones. The cross-section of the boundary plane was clad in black aluminum. This light-absorbent surface flattened dimensional relationships between rooms and camouflaged the thickness of the interior walls. Each of the 6 rooms was illuminated with fluorescent white light. As the visitor crossed each threshold, the eye compensated towards color neutrality. The perceived difference in light temperature became a significant tool for marking spatial change. Digital models of lighting failed to explore this process of optical accommodation to the light environment. The studio developed a large-scale physical model to study the adaptation of the light of the eye to changes in light temperature. In the physical model, each of the 6 rooms was fitted with identical fluorescent bulbs. Bulbs were kicked to the warmer or cooler Kelvin values using theatrical lighting gels. Here we see a conversion chart describing the chromatic shift between a light source, the filter, and the resulting light. And here's a little example of how this chromatic shift would work. Let's say your initial bulb starts with a daylight Kelvin value of something in the range of 2,000. I'm sorry, 7,000 is what we're looking at here. If you attach lens 204 or filter 204 around that bulb, you'll end up with a much warmer Kelvin value as an output. Notice here that then these gels were schematically divided between the 6 discrete zones and color-coded in this drawing in warm or cool. And then a series of different iterations were set up inside the studio where people would study, walking around this model over and over, the relationship of changing these filters out, and observe which had the greatest perceptual alteration or shift from one zone to the next. New fluorescent bulbs were installed in existing light fixtures, each corresponding as closely as possible to the prescribed Kelvin value from the model. Much like the human eye, the camera serves as its own frame of reference. Color correcting for white neutrality, areas and adjacent zones appear extremely warm or cool. .33D, created at Kunsthaus Baselland, was also developed for an exhibition space illuminated by a fluorescent lighting grid. Daylight saturated the elongated space, shown here, entering through a row of windows flanking the eastern wall. Our light studies indicated that the imbalance in luminous intensity between daylight and the gallery's fluorescent lights was extreme. It rendered all modification to the existing artificial lighting imperceptible during daylight hours. Our light studies changed. Our first explorations involved the division of the exhibition space into lighter and darker zones. We anticipated radical changes in relative luminosity throughout the day. The directionality of daylight created differences in the boundary's surface illumination. One side of the boundary was bright, one side of the boundary was in shadow. Here, illuminated surfaces are indicated with a thicker white line. Two segments of the boundary planes, indicated in bold, were comprised of glass. The materiality of these planes impacted the occupant's perceptual field. The glass appears reflective from the brighter side and transparent from the dimmer side. Changes in relative luminosity shifted the volume of visible space. What is reflective during the day is transparent at night. The perception of spatial adjacency changes over time. Sightlines can be diagrammatically reduced, highlighting critical relationships between viewer and boundary. In 33D, one such critical relationship is between the axis of precession and the view to the exterior. As the inhabitant enters, they encounter a transparent glass surface. looking through the transparent surface, they can view the reflective surface beyond, oriented at 45 degrees, both to their axis of precession and to the light source. Once the viewer crosses this threshold, the glass on either side appears reflective. The illuminated glass surface reflects the view of the exterior. From the far end of the gallery, looking back towards the entrance, what was initially transparent is now a reflective surface. And what was initially reflective in prior slides is now transparent. The glass is structurally supported by the thickness or within the thickness of the boundary plane, both from the upper detail and again in the lower detail. It allows the glass to hover off the floor by approximately 1 centimeter. S281913 was located at the Pérez Art Museum in Miami. The plan of the museum's second floor suggests a range of possible paths through the building envelope. Notice. The undivided processional space weaves between discrete boundaries. This processional space is flanked by 4 enclosed rooms, here, 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 and here. And these 3 rooms all have a similar rhythm between the doorway entrance space and a single window to the exterior with a change in orientation. However, the dimensions of these windows and the dimensions of these thresholds are identical actually for all of these 3 zones. Programmed as focused galleries, each of these discrete rooms are defined by a threshold, poured concrete walls, and the presence of a single window. This cell-like arrangement heightens the visual relay between threshold and window. This cell-like arrangement heightens the visual relay between threshold and window. Neither columns nor contours interrupt the visitor's line of sight within the bounded gallery space. The spatial uniformity of the gallery appears to make the study of a viewer's sightlines unnecessary. As we have seen, however, a viewer's frame of reference develops relationally. A number of tools have evolved to study the reference frame of the perambulating viewer. From early applications of cognitive mapping to J.J. Gibson's analysis of optic flow, perception has been conceived as an ever-changing relay between environmental stimuli and human cognition. The Isovist is one such mapping tool. This tool is central to the studio's exploration of the reference frame of the moving stereoscopic agent. Developed by urban planners in the 1960s, the Isovist represents the volume of space from a single point at 360 degrees. Working in collaboration with programmer Andrew Human, my studio developed a custom script that allows us to parametrically model the Isovist, a changing volume of vision defined by the relationship of a moving subject and a building envelope. The Isovist is dependent on the relationship between the total architectural volume and the position of the viewer. The definition here, shown here, automatically updates as the isovist as the viewing position is moved around the volume. The simplification of the room's spatial features heightens the perception of daylight. As morning becomes afternoon and winter becomes spring, sunlight creates a predictable set of fluctuations in the visitor's visual field. The isovist is also determined by these environmental factors. In S281913, two glass boundaries reroute the flow of daylight through the room, reshaping the volume of visible space. Daylight floods the window. The clear planes become highly reflective surfaces when viewed from their illuminated face, creating a predictable volume of vision. Upon entry through the articulated threshold, the visitor encounters an illuminated image of Biscayne Bay. As the visitor passes through the threshold, their isovist shifts and shifts again. Simple changes in viewing position radically alter the space of the isovist. What was moments ago reflective is now transparent. Not only is the viewing position of the viewer in flux, the boundary is also moving, overlaying the periodicity of illumination and precession with a third temporal frame, the motion of the architectural apparatus. The additional temporal variable destabilizes the perceived stasis of existing boundary planes. At the Perez, the apparatus's axis of rotation reoriented the ground and ceiling plane within the visitor's visual field. The museum's iconic lighting grid, seen here in this reflected ceiling plan, is juxtaposed with the reflected view of Biscayne Bay. Visitors were both viewers and actuators. Manual manipulation shuffled overlapping temporal cycles of illumination, precession, and boundary position. Motion blurred the boundary of the artwork, undoing conventional relationships between viewer and viewer, viewer and guard, and viewer and curator. The movement of S28 is derived from the more conventional rotation of standard architectural elements, such as windows and doors. An examination of the representations of these time-based technologies calls attention to the limits and possibilities of architectural drafting. When it comes to the building in motion, drafting conventions are largely limited to the representation of a pivoting door. The turning of a door is drawn as an arc in plan. This arc represents the total possible positions of a door, the door at all times. 360-degree rotation extends the arc into a circle. When the trace of this movement is viewed in elevation or at eye level, the circular path appears as a line. While developing S28, the studio began to study the orientation of this rotational axis. The geometry of the glass volume in this early mechanized prototype is based on the insulated glass unit, also known as an IGU. 2 layers of glass are separated by 2 aluminum bars. A volume of air is sandwiched between the glass planes. By orienting the axis at 45 degrees, the rectangular element rotates from vertical to horizontal. This reorientation of the axis of rotation transforms the apparent path of motion from a circle to an ellipse in both elevation and plan. The representational convention of multiple viewing planes, naturalized in the 4 viewports of computer-aided drafting systems, became an essential conceptual guide and methodological tool in the project's development. The point of view in a representational system became inextricably linked to the point of viewing in processional space. The orientation of objects and the position of bodies developed relationally. Not only does the glass boundary plane rotate around this central axis, but each internal mechanical component also rotates around this axis. A detail of this mechanism is shown here in section through the axial center line. In order to develop these moving parts, the studio constructed multiple reference frames within our digital and physical models. Coordinate systems allowed for rapid translation between the world's vertical axis and each object's primary reference frame. These new frames of reference allowed us to study the relational transformation of each component throughout its rotational path, and to predict potential interference between the multiplicity of moving parts. S337473 at the Wexner Center for the Arts examines, distorts, and exaggerates a very different architectural frame. The Wexner Center's exhibition spaces literalize the logic of rotation. The building translates 2 different urban axes into 2 divergent structural grid lines. Intersections between grid lines result in staggered pairs of interior columns, seen here. These columns punctuate and interrupt the visitor's visual field within each gallery space. S33 realigns the column grid and the experiential axis of procession along a 45-degree grid in plan. In order to twist the viewer's visual and processional line of approach, S337 required modifications to the existing site. The ramp wall, here, is lowered to allow for sight lines between circulation and exhibition spaces. A sheetrock volume is constructed, enclosing the 2 centrally located columns. This central volume is approached on its corner, accentuating passage along either side. Pivoting thresholds are positioned at 45 degrees to the primary axis of procession. Each threshold bridges and marks this passable space, regulating flow between zones. S337473 is first encountered by the visitor as they process upwards towards the entry of the gallery space. Positional change is activated through manual manipulation. Like S281913, S337 also rotates along a 45-degree axis in elevation. Unlike S28, rotation around this axis transforms a lintel into a column. And back again. In order to avoid collision with the building envelope, rotation is limited to 180 degrees. The limited arc creates radically different dynamic forces throughout the rotational cycle. Controlled acceleration and deceleration became critical to the work's dynamic trajectory. The studio developed a script to explore rotational tolerance parametrically. Dimensions are numerically defined. The rotating element can be reoriented along the X, Y, or Z axis. The path of rotation updates automatically as geometry is modified. And most importantly, collision during rotation is marked and positional change is traced as volumetric form. The location of the joint along the length of the rotating bar can be moved to avoid this collision. In an ideal world, the glass element will have a constant velocity throughout a full 360-degree arc of rotation. The digital model presents the work in an ideal state. Any imbalance due to material specificity or sighting creates irregularity in motion, resulting in significant changes in acceleration and velocity. A study in equilibrium was developed at the Wexner Center in collaboration with OSU's Department of Mechanical Engineering. Here, sensors measure the acceleration and angular velocity resulting from unequal weight distribution across the axis of rotation. The ideal model demonstrates constant speed throughout 360-degree rotation. The red line represents angular position over time. The blue line represents angular acceleration over time. The black line represents angular velocity over time. In this artificial state of dynamic equilibrium, velocity and acceleration stay constant as the element rotates. In the empirical model, imbalance across the rotational axis creates eccentricities in movement. How might equilibrium be achieved? When pivoting the artwork on site, it became apparent that the work was not balanced across its rotational axis. The script was further developed to address this imbalance. Green volumes represent positive weight values. Red volumes represent negative values. The volume of the counterweight changes as its material density and position are modified. Adjustable counterweights were buried within the cavity between glass planes. Here. Weights offset imbalance and return the piece to a state of equilibrium, calibrating threshold movement over time. At times, the threshold appears opaque, and at others, transparent. Transparency is determined by the position of the glass, the position of the sun, and in this case, the position of the camera. S337 is constrained by the building's boundaries. Tightness and tolerance between the rotating elements and the surrounding building surfaces generates spatial tension. This tension between boundaries is at the core of the studio's latest investigations. In SO11110, a horizontal glass beam rotates around a vertical glass column. Had the beam been any longer, it would have collided with the column. SO11110 avoids collision through the dimensional constraint of the rotating element. Beam and column are connected through a pair of linear rails. The dynamic joint slides between the rails and can lock into position at any point along the length of the glass unit. This linear track allows for positional calibration of the beam's center of mass. During installation, the beam's position can be adjusted to achieve dynamic equilibrium. And here you can see a detail of these locking linear rails. This connection detail revealed a remarkable opportunity for future work, or the future phasing of temporal change. Here we see two dimensionally identical models. On the right is the original 360-degree rotation. On the left, an oscillating linear movement has been coupled with rotational motion. The temporal coordination of linear and rotary motion eliminates collision. This temporal phasing is critical to the perceived relationship between boundaries. The tighter the tolerance between dynamic and static elements, the greater the perceptual tension. The timing between linear and rotary motion must be precise. How might this phased timing be developed? Like the circular arc of the door swing, the total possible positions of the moving element must be analyzed. The path of motion here appears as an elongated parabola. Rotation is coupled with linear oscillation. For each 360-degree rotation, the plane completes 2 linear oscillations, meaning it travels back and forth 2 times. The path of motion is determined here, or the difference in paths of motion is determined here by the phasing of temporal cycles. Boundaries delimiting our environment embody an extraordinary dynamism. They both shape and are shaped by the temporal cycle of the architectural frame. This frame is a determining characteristic of contemporary art. The spaces of exhibition, the logic of their operation, and the iconic public face of the museum increasingly determine forms of new work, often fabricated specifically for display in museum galleries. These institutions often rely on archives of digital files, construction documents, capacity studies, light and temperature analysis. Computer-aided design allows for this information and proposed alterations to the built environment to be shared between parties without material consequence. The studio's use of Rhino, CAD, scripting, etc., allows for a scalable practice that integrates with these particular contemporary conditions. This integration into conventions of information infrastructure raises a central question regarding the possibility of institutional tolerance. Light projection and performance are remarkably scalable and adaptable to the architectural envelope, well suited to vast spaces with relatively small budgets. Institutional friction is often minimized and context is erased by live bodies and moving images. The methodology of digital architecture shares the scalable possibilities of light projection and performance, but deviates at key points. By adopting the procedural methods of architecture, an artwork is able to operate within an evolved, pre-existing codified system of information flow and material manipulation. Friction arises precisely at the moment that the invisible rules underpinning the architectural envelope are questioned. Importantly, this friction is not limited to the symbolic realm of building code, flow studies, and structural requirements. This symbolic system is materially manifest in the inhabitation and the construction of architecture. Spatial manipulation has the potential to transform this symbolic exchange into an experiential reality, allowing human actuators to reposition their architectural context. Thank you.
Great. Sarah will welcome your questions.
Thanks for the talk. In
Hello?
the Perez Museum, was that me or you or something?
Go for it.
In the Perez Museum piece, were you saying that the guards or museum attendants were helping them to rotate the pieces?
Yes.
Okay, that's it. Thanks.
Hello, thank you for the lecture. I would like to ask kind of a silly question. Why are the metal parts black, and what would happen if they were different colors? Thank you.
That's a really good question. The metal parts, the blackness of the metal parts has been an evolution, but I have found that a matte black surface is perhaps the most effective way of erasing depth perception. And because there's such extraordinary tonal contrast often with the surrounding space, and this is particularly true in spaces that have white walls, it affects a sort of dissonance where you stop being able to read the detail and the change in geometry that's occurring within that black plane, or planes. And I want to say one other thing to answer the question about the guards. I think something that isn't discussed here, but would be a really interesting sort of space or topic for a lecture, is how museum inhabitation or the museum's visitors' experience is so highly curated already by the presence of and the interaction or the seeming non-interaction with the guard and the figure of the guard. And these projects led to a set of institutional questions and negotiations that were very much, I think, stretching the general protocol of the institutions in question. And the guards became sort of right in the center of that conversation in a way that was really interesting, I think.
Thanks for the talk. Scott was right. It's extremely architectural, and it's. I'm like very envious of the fact that you have like such a clear goal in mind, and as a result, you have a clear sort of empirical way to judge the work, whether it achieves this sort of optical effect that you're striving towards. That level of clarity and the intention also with your actual like modes of representation in terms of the drawings that we've been looking at today and your extreme close relationship with engineering details and things like that seems very architectural. The question I have is that maybe perhaps in that vein of like art versus architecture, there appears like a deviation in the work. Firstly, it seems like to me, the primary goal in the first half of the lecture with your interventions on space, the work itself like completely disappears. I was so like overcome with a desire to kind of like optically, spatially understand what I was looking at that the actual thing itself, your steel and glass intervention as a medium, again, it disappears. Whereas in the second half of your presentation, the sort of object of focus totally shifts back. And it's no longer solely or primarily about the sort of spatial reconfiguration, but is about this more sculptural, like Calder-esque thing. And so I was wondering if you could speak to that distinction and what may have perhaps like inspired that change of thought.
So I think that that's a really rich question. I think there's a lot to be said, so I'll try to address it succinctly. First, I think it's very important to point out that for each of the projects for all of the projects that I spoke about today, I think of there being two very specific kind of conjoined moves, if we think of them as a move. One move is about the reconfiguration of the existing situation such that you can't actually tell how it has been changed. Or it is hard to name how it is changed. So for example, in the last picture or the last piece, SO1110, I lose track of the titles. It seems as if the space is as found, and the piece has been imported into that situation. And even to people who had been to the space multiple times in the past, it probably was perceived that way, much like the first piece. that I showed. But what happened was, like the first piece, the beams were in a very different position in the ceiling. So rather than shifting the boundaries in the wall, what was shifted was the distance of the ceiling from the structural members that ran through the ceiling. And so the two moves, as I'm talking about, one has to do with this kind of shifting of the existing building envelope, and the second has to do with an insertion. And part of the balance there is always how to make what you make visible and what you don't make visible. And so there's a tremendous amount of work that's actually not visible in these works that are moving. But it also became very clear to me, and is becoming clearer and clearer over time, that when something moves, it's hard not to experience it as entirely separate. And so how that balance starts to play out in the future is a question for me.
One of the thoughts that I had was, like, would it be possible to combine these two different types of sculpture, so that if you were now fascinated with equilibrium and things like that, could you now reapply that to the question of, like, the wall?
So here is this
like
the
major.
answer. I'm incredibly excited about the coupling of linear and rotary motion, but the coupling need not occur in the same object, meaning one thing can slide and one thing can rotate. It's just about, in a machine world, it's just about what's fixed in relation to what, basically. So it could be that the glass rotates and the wall moves out of the way. And that relationship then is really up for grabs, how that embedment works and what is static and what is moving. So the answer is yes, definitely.
I felt like a lot happened at the very end of the lecture, so I just kind of wanted to jump back to something I'm thinking about, where it seemed like you were opening from the phenomenological to the institutional framework. And through the kind of time-based medium of exhibition. And I heard two other characters come up. One was light projection and one was performance. And then the kind of sculptural or architectonic practice, which might actually be both one of light reflection and performance. But I was wondering, I didn't quite understand or didn't quite catch what you were setting up among those three terms of light projection, performance, and your practice in relation to the institutional, informational framework.
So I'm happy to try to clarify that. One thing that I have seen to be increasingly the case in contemporary art is that the Contemporary Art Museum is addressing a very different scale. And it's also addressing a very different set of problems, which are not the problems of showing small, discrete paintings to a contemplative viewer, but of creating a kind of large social space that is vastly overscaled to the human body and has some sort of iconic relationship to urbanism. And those spaces and the curators of those spaces are in a situation where it's very challenging to, let's say, fill them. And the notion of filling then becomes a really, like a troubling one as someone who is expected to be a filler, because it shifts the possibility of what is that, what are you doing? And does that envelope then radically alter the direction of not just what we recognize as contemporary art, but also what is being made as contemporary art? And so one way that I think that has been neatly dealt with is to deal with moving bodies and light projection as ways of filling spaces without massive quantities of capital being required to do it, like building a huge second building inside the first building. And I think that digital architecture, what I mean by digital architecture is this possibility of playing with the manipulation of the building without actually manipulating it materially is nicely within that paradigm. It has no, but like massive.
So akin to performance.
Yes, exactly.
I want to I imagine you've been asked about this. The possible association with your work has with that of, believe it or not, Mata Clark. I was just in Bronx to see a great exhibition. I don't really want to ask you whether you agree there's an association. I want to just put something on the table. I was thinking, I mean, when you mentioned the protocol and stretching it, that's what really brought it to my mind again, because of course what he did in overlaying his acts of destruction onto buildings that were, being destroyed, and idealizing their destruction in the way he did, for example, by carving a perfect sphere out of the building in Paris while the building's undergoing demolition, et cetera. These were very dangerous, and they were outside all kinds of, all kinds of issues of like working outside the norms of what it meant to do a work like that. But I thought it was very interesting that you too are doing something that is creating these problems. But I think the reason, it seems to me, and I think you just said it, it's digital architecture. I mean, what was so poignant and so powerful for me was when the giant beams were rotating, and of course, the forms of rotation being overlaid is absolutely essential, as you've pointed out again and again. You were enacting what we all do. The elastic transformation, that scale 1D, everything that's happening in our modeling is being enacted. We are actually experiencing the weightlessness that is manifest. I feel like you're doing with digital working of architecture and the revision of the digital model that we do normally only in modeling. You're activating it in a manner, for example, analogous and inverse to what he did with the physical undoing of buildings. There's something to it. I need to think through this. It's kind of amazing. Do you know what I'm trying to get at? It's like you're embodying a process that it was sort of never embodied. I mean, we do it all the time, but we can't embody it. I mean, the students are look, right. The way you're working is what we're doing in our modeling all the time. When you said you lowered those ceilings.
So I have many comments, but I think it is essential, and I think an essential distinction, that these buildings are inhabited, that these buildings are lived in and used and remembered and inhabited, and I guess in some ways it becomes very important that these buildings are actively inhabited through the transformation that through the set of operations that I perform on them, let's say. But I also think that what you're describing about this material embodiment of a digital manipulation is really interesting, and that one of the key surprises there is that so much of what we think we know digitally, we don't know, because there are so many proprioceptive experiences that are absolutely vacated in any kind of screen display. And so gravity, which is the thing that this rotation mostly defies, and equilibrium, which then gives it the grace of the impossible, that's the non-visual key to that transformation. It's not a visual problem. That's why equilibrium is at the core of it, because it's that which the digital cannot simulate in some felt way.
I don't want to hold the floor anymore. So.
Really great stuff. I was privileged enough to be at the opening of your work at the Wexner Gallery, and it was truly remarkable stuff. I was interested in the naming of the projects. I think that the act of the artist or the creative naming their work usually has implications as to how they want the work to be received or something like that. And to me, when I hear the names, I sort of think of like the level of precision required to make these amazing pieces come to life and to work. But I was wondering if you could speak on that as to what informs the naming of your projects.
Yeah, I would be happy to. The naming has been in place in some form, in a schematically similar way for probably 10 years, or more now, actually. And it evolved specifically as a way of thinking about the work as not site-specific. And it had to do with thinking about how there are basic rules underpinning the organization of architectural space, such as, let's say, a fluorescent lighting grid or different types of building code, handrail heights, et cetera. And that had to do with how every time I would develop a work, that work was developed not so much for that specific site, but for a set of conditions which could be found in any number of other locations. And kind of the organizing principle about those recurrent conditions is the idea of adjacency. So the titles are basically based on a spreadsheet, which starts with a set of adjacent zones and looks at the manipulation of the boundaries as a possible variable, 0 through 9, for each column of the row of numbers, and talks about how flow would act between those zones. And that includes things like airflow, light flow, vision flow, bodily passage, et cetera.
Thank you for the talk tonight. You showed us a lot of your work, which are interventions in interior spaces. I was wondering if you could talk briefly about sort of the challenges of working with outdoor spaces, public spaces, things like that.
Well, there's lots of different types of challenges that I see in that, in let's just call them exterior spaces, some of which are public or some of which are perceived to be public but are private. I think one question that arises for me is very much what happens to the conditions of adjacency or the conditions of a boundary when you move outside. And also there are very different histories of art action or art production or sculpture, I'm not sure how you want to name this, once you remove the interiority of space. And for me, both of those things come into play in thinking about taking the work outside. Additionally, and I think something very importantly, is that the navigation, let's call it institutional navigation, but the navigation with the parties who control the space are very, very different. And I think those questions would really reshape how I was dealing with project.
Well, Sarah, this has been wonderful.
Thank you.
And everyone I know is so excited about what you're doing in the school. It's been just a great experience for all of us. So everyone, thanks Sarah.